Hi, everyone. Welcome to my talk, Unmasking the AI Illusion. Before we begin, I'd like to introduce myself first because I'll be talking at you for 45 minutes. My name is Michael Demey. I'm the research manager at the Prize. That means that me and my team, we prototype every day. We write new code that may or may not get to production. We work on standardization, and we do developer marketing. That's why I'm here today as well. I'm also a PDF expert, which sounds a bit strange, right? And for those of you who don't know, Belgium has 5 PDF experts, 2 of which are in this room right now, so that's a huge buzz factor as we speak. Shout out to my fellow PDF expert in the room. He flew especially in today for me. Next to that, I'm a bass player. I love playing music. We've been talking technology all week already. If you want to talk music, feel free to find me on the conference floor and talk music. And my second daytime job is being a dad to 2 awesome children who are quite a handful, but are very, very awesome. That's my handle there at the bottom. It's mymilkedeek. Feel free to add me on anything that you want, but to know that ever since somebody took over Twitter, I'm not really active there anymore, for reasons, as you all may know. I work for a company called The Prize. We have a line of products that all revolve around document processing. So we have a web viewer that allows you to integrate PDF viewing, document viewing into your browser, editing, etc. We also have signing solutions, PDF editing and management solutions under Xodo. And the other solution that we also have is iText, which is an open source PDF library written in Java. Feel free to check out our stuff online on our website. We also have a booth down here. It's when you go down, it's in the left corner. Feel free to come talk to us there. We like to hear your use cases, and there's a code challenge if you want to win. I think it's a Darth Vader Lego set if you want to win it. Seems awesome. Okay, so let's go on to the actual presentation. And we've all seen it this past year and a half, right? There's been an AI explosion. There's been tools everywhere, toys everywhere, lots of new ways to generate content in funny ways, but also in some disturbing ways. I find them exciting. They're a bit controversial because of things that may happen. People get fired over AI tools and stuff like that. This is not going to be the purpose of this talk. I'm not going to talk about the morality of it. We can talk that over later over Coke or something, but we're not going to talk about that here. We're going to talk about what is AI and how can we differentiate between normal human-generated content and AI content. But first, let's go over a few highlights to indicate how well it's been this past year and what the dangers are and why we need to be able to differentiate between the two. But first, let's look at the funny ones, right? This is the best one, in my opinion. It's at least... Oh, the screen is going crazy. But you can tell what it is. It's a Matrix-style Pope depiction. So we all know this image, right? It's an image of the Pope being dope. He was wearing this vest that if any marketing department would use it, I would buy it immediately if they would slap on some branding. I would buy it immediately. But the interesting part of it is that it's really deceptive. You could deceive a lot of people with this if they're not paying attention. Of course, if you know the Pope in the papal office, they're not going to let him wear this ever whatsoever. And then the next one, I had to include it because it popped up this week, and I just laughed at it. It was very funny. It was making the rounds on Reddit. And it's just this guy battling an alligator over pizza. It was really funny. Another example, which isn't as funny as it is interesting. It's a very non-noteworthy image, in my opinion. Of course, tastes differ across people. But the interesting part about this is that people start entering AI-generated images into art competitions. And this one dude, he won. And the other artists weren't happy because they put in the effort. They put in the effort in learning the craft, in making the actual image. Whereas this guy, he just wrote a prompt. But there's a discussion to be had there. I mean, in the end, it's all about the outcome, the product that comes out of it. And if I commission somebody to make a painting, I don't care if it takes 1 hour or 10,000 hours, to be honest. But it's a discussion to be had outside of this conversation. Another thing that popped up this week was Tom Hanks, his imagery and his voice being used for a dental plan ad, which he didn't consent to. He put out a message on his social media that he did not consent to it, and it's a fraudulent use of his imagery and his likeliness. This, of course, is already being targeted by current legislation, as illegal as it is, but it's interesting how well the technology has progressed, that it can be used to such an extent. And I mean, it's funny when The Simpsons do it, when they bring on Michael Jackson as a sort of Michael Jackson impersonator, right? But it's not so funny when they have you calling your grandmother in distress on the side of the road because you crashed your car and need money wired immediately for towing a car. That's not so funny. It's a very dark side to AI that we should not overlook. And in some cases, we cannot discern between AI and human-made content, especially in a case like this, because it's just hard, right? Nobody has the tools at the point, especially not in a panicky, stressful moment like this. Nobody has the tools to discern, to differentiate between the two. So there's a lot of dangers associated to it, especially because currently AI, it's a fun tool, but it's only going to improve to a point where it's going to be indistinguishable, at least from the majority of it. And to a point, it's already there at some pieces of content. But I think like the danger is also in politics. Just to give you like a real-world example, like smear campaigns are only going to get worse if we don't contain this, and to some degree. Google already updated their terms of service, I think, in September, or they're going to update it in November, that political ads, if they use AI content, should include a disclaimer, which I think is not going far enough, but it's at least the first step. So the question that's on everyone's lips, right, after this general AI introduction: how can we identify AI content? Well, we're software engineers, so our first response is let's automate this. Let's fight fire with fire. Let's use AI to detect AI. And that's what our first initial response is. I think it's a very valid response. We know how to do this, and so let's try it. And that's what OpenAI did. Back in January of this year, they released a detector, a classifier, that would take an input of text and then would output yes or no, was made by a human or was made by an AI. So they were very happy with it. They released this on a very ugly-looking website. I really had to crop it down because there was an even uglier image to the right of it. The funny thing, or at least the depressing thing about this, is that not like 5 to 6 months later, they announced that they had to retire this detector because it was very inaccurate. I think the rate of false positives on human content, so it would flag it as AI-generated content, was way too high for it to be usable in any kind of way. So they retired it. They're improving on it, but I think it's telling. I think it's telling and a bit worrying, at least to me, that the people behind ChatGPT trying to tell you whether or not content was made by ChatGPT can't do it in a trustful way, in an accurate way, and with a high efficiency rate. So that's a bit concerning. And also, I don't think that's the right approach, because I'm not too deep into the AI technology and the tools that have been used, but to me, it seems that you can use a detector to reinforce your learning algorithm, to use that as a sort of input and improve your generative algorithm, which, of course, is an arms race between one going faster than the other. It's always a catch-up game. So while we shouldn't completely stop following this path, I don't think this is the way to go. So I do think that we do need to think outside of the AI box. There are more things than technology, and there are already things in place that we can use. I'm going to look at one solution today because it's in the margins of my day job. It's in the margin of standardization that we do. And it's a standard called C2PA. C2PA is an open standard. If you Google it right now, you can go on the website, you can read the specification A to Z. That's what I told my team members to do. I did that as well. But it's an open standard. You can read it. You can contribute to it if you become a member of the consortium. And C2PA is a standard that allows you to track the origin of types of media, of images, of videos, of sound clips. And any file that you can imagine, you can trace the origin of it. So C2PA, because it's an acronym, so we're going to take the time to explain it. C2PA stands for the Coalition for Content Provenance and Authenticity. So that's quite a mouthful. So I'll break it down for you guys so that you at least know what we're talking about. I'm not going to explain the word coalition because I do hope that you know what that word means. If you don't, come down to the booth and we'll talk. But it's a word that, at least in Belgium, you hear a lot. So the first part, content provenance, it means proving the origin of content. I put and authenticity in parentheses because it's a bit ridiculous to include authenticity in the definition of provenance. But that's what it means. So proving the origin of content. Where did content come from? Who made it? Using what devices? What tools did he use or they use? Authenticity is proving the author of the content, like proving who made it. Can we trust that person? Can we trust that he is, that they are that they say they are? And that's what C2PA is trying to do, trying to prove the origin and trying to prove the author of the content that you're trying to consume. So it may seem that it was like initially set up to be a standard to combat AI, or at least to identify AI tools. But the initial goal of C2PA was more to combat misinformation and disinformation. This is something that came up a lot in the previous decade, like active campaigns of disinformation going out, or just ignorance. And this is a tool that allows us to identify at least part of that solution. Well, let's maybe look at who's behind the consortium first, so that we can see why it's against misinformation and disinformation, because it's not only software vendors that are behind this. If you look at who's behind it, we see big names, right? Software-wise, we see Adobe, Microsoft. You could say Sony as well. But you see hardware vendors like Sony, Nikon, and Canon are on there as well. We see media companies, the BBC, not on here, I think, but Reuters is there as well. And the RIAA is on there. So it's like a mixed bag of interests. And that is because misinformation and disinformation goes beyond generated content. It's like articles that aren't right, or photographs being used incorrectly to frame a certain article in a different light, which is something that does happen. And that's why we have fact-checking on multiple news websites. So let's dive a bit into what C2PA does. How does it work? Let's assume you take a picture, and initially I thought it was of the pyramids, but it's the mountains. So you take a picture of the mountains and the sun. And as we all know, images, they have metadata associated to them, like what's the color profile of the image, what are the bytes, how do we encode it, and then what's the non-technical metadata. I'm not sure if it's legible on the big screen, but that's like who made the picture. That's not something that you can trust because anyone can change that. That's in all the specifications of every image type that you know that provides metadata at least. So you can Google these and you can read them. C2PA, and I'm going to zoom out quite a lot, don't worry, we're going to zoom in back again, allows you to insert a lot of metadata into a file. They call this the manifest files. You insert a manifest file at origin, like when you create the image, but then every step along the way, you can also add more metadata. Let's zoom in a bit on the first step, which is the creation of the image. So the metadata here will tell you the type of camera used. In this case, a very generic CC18 by camera company, apparently. The location was in Piedmont, and the time and date are also inserted. This picture was taken in August, or in May if you're in the strange part of the world. Zooming out again, and I'll go back one slide, you see that we have multiple things that we can insert, and for instance, the second step there, going from the back, is adding a color filter on a certain date made by Edit Suite. The other step that we take is we add compression and we add a caption to it, sun over mountains, and then we publish it on the news broadcaster, very generic names. So this is what it looks like in a graphic. My team has made 3 prototypes. Excuse me. First of all, to insert this data into PDF files. Secondly, to validate this information. And then we also have written this visual tool. As you can tell, it's a developer tool. We're not designers. And this part here, so I inserted a manifest into a random PDF file that I have. And I inserted manifest file. And in here you can see the keywords. I'm not sure if it's legible completely, but in the red rectangle, there's Devox 2023, and the context and my name is there. So this is just, as you can tell, it's just a JSON file that has been included. So wait a minute, whoa, surprise. If it's just JSON, if it's just bytes, can't AI include this manifest file into any picture it generates? And you'd be correct, right? Because in itself, the C2PA manifest files, they aren't magical, they aren't mysteries of life. It's a publicly available specification, as I mentioned. You can go to, I don't want to say the website because I might be wrong, c2pa.com.org, Google it. It's publicly available, you can read it, you can implement it yourself if you take the time for it. So there is something else that we've done, or at least that the committee has done to make sure that you can trust the manifest file that has been included. Because the manifest file in itself doesn't include like the specifics of who made the file. So the question is, how do we tie the author to the manifest and to the content? And every time, at least in PDF land, when we look at authenticity and proving authorship, we'll look towards digital signatures. They arise from the heavens and they ascend down from us. So we're going to look at digital signatures. C2PA uses that. I'll briefly explain what signatures do. Usually this is a talk condensed to an hour, so I'm going to try and speed run that hour in a few minutes now. Digital signatures, they have three goals, three main goals when we talk about signatures in files. They want to prove integrity, they want to prove authenticity, which we already talked about, and they want to provide non-repudiation. So we'll zoom in a bit on each of these terms. So integrity. This is an excerpt from a newspaper with a very Flemish-looking older guy. And Eddie is doing some reconstruction, like renovation work in his house. And he pays a contractor, he gets an invoice every month, every 3 months, doesn't matter. And he, as a good citizen that he is, he pays that invoice every time he gets it. So what happens? A scammer finds the invoice, changes the bank account number to his own, and then just puts the letter, the invoice into Eddie's inbox, into his letterbox. Eddie has no way of checking, or at least doesn't have the common sense to check the bank account number. Even if it differs, you know, companies have multiple bank accounts sometimes. So you need to contact the original owner again, and he didn't. He paid the amount, and yeah, he lost that money because he paid that to the scammer, and he still had to pay the original invoice. So not very happy. Eddie is not very happy. If Eddie had a way to check that in a quick and easy way, then he would not have lost 30,000 euros. It's painful. So integrity, it's proving that the content, or at least knowing that the content of a document or a file has not been changed without knowing that it has been changed. So for a classic example without malintent is a download that has corrupted. So you want to check if the download has been correct, or if you download the correct file, that would mean that you would do an integrity check. So making sure that the content is still the same content as you think it was. Then the third definition is authenticity. This is a mural or a tapestry, I can't really tell, of Emperor Constantine I. He was assumed to have transferred his powers to the Pope through a letter. Apparently, years later, centuries later, that letter was, they discovered that letter was a fake. It did not come from him. Well, the letter was real, but it did not come from him. So it was assumed incorrectly that Constantine I was the author of that letter. Of course, back at the time, you can't pick up the phone and ask Constantine I, did you send me this letter? So authenticity is about proving the identity of the author. There's easy ways to do that as of today. Then the last definition, the last goal that we're trying to achieve here is the goal of non-repudiation. So non-repudiation, aside from being a very good word to play in Scrabble, is a big word that basically means that you make sure that the author of content of a document cannot deny that he was the author of a content. For instance, Bart Simpson here, writing his name in wet concrete, he says, "I didn't do it," even though we clearly have the evidence that he did it. So non-repudiation is about making sure the author cannot deny his authorship, being the author, and in this case, of the signature. So how do we achieve that? We have a few technical concepts. I'm not going to go too deeply into them, mostly because I will assume that you will know some of them. We have hashing. Hashing is a mathematical function in which you input bytes and out come another series of bytes. It's a one-way operation, normally. And the operation is also deterministic, meaning that every time you perform that operation, the same input will produce the same output. So earlier we talked about integrity. If you download a file, if you download a document from the server, and you want to check if it's still the same file, you can generate a hash and then compare that to the hash that the server can and should provide you. Given that these documents, or at least the hashing algorithm, is deterministic and consistent, they should be the same. If they're not the same, if they don't have the same output, then the document has changed, has been altered, corrupted in some kind of way, and you should not trust the file that you have downloaded. So that's the first concept that we'll use. The second concept that we'll use is in the technology of asymmetric keys. So asymmetric keys are all about key pairs. You have a public and a private key pair that are linked together. And on the slide, the public one is the green one, and the private one is the red one, or orange. And the concept behind them, very, very shortly explained, is that whatever you sign or encrypt with one, the other can validate and decrypt. And it's a one-way operation, so a public key cannot decrypt its own encrypted messages. So the interesting part about that technology is the applications that it has. You can apply it in two ways, right? You can use your public key, or you can use your private key. And it's I forgot to mention, but it's in the words itself already, but you do not proliferate, you do not share your private key. It's in the word, it's a private key, don't share it. So whatever you sign with the public key, it's only going to be opened by your private key. And given the fact that you only have access to your private key, and the whole world can have access to your public key, that means that anyone can send you private messages. So if I want to send a message to my fellow PDF expert in the room, I can use his public key that will give us a jumbled set of bytes, and then his, or encrypted set of bytes is a better way to put it. He can use his private key that's private to open up that message. The reverse can also be applied, and then the actual action and the consequence out of that is that we can prove that a certain key was used to sign a message, right? So if I can use my colleague's public key to open up a message, that means that his private key was used to sign it, and only his private key, normally. So these are the two concepts that we pull out of that. We got encryption and digital signatures, and we are more interested in the second part, the part where we use the private key. So that's the first step that we can have to proving authorship. The second step that we'll need, especially with the private keys, is a way to assign private keys to people, because you can create private keys, public keys on your machine right now. You can create them by the dozens if you want to. So the thing that we introduced, and this is again outside of the technology, but more playing around with the technology, is the concept of a certificate authority. A certificate authority is basically an organization, a company in Belgium and in Europe. They are countries, governments, that hand out key pairs. They are signed and they belong in a chain of that certificate authority. For instance, in Belgium, if you have your ID card on you, then that was given to you by your government, by your local government. And that key, that ID card contains a key pair that was signed by the government. And the way that it works, if you sign it, that means that you can retrieve the origin of the key out of the key, meaning that you can see this key was provided by the government, and we trust the government at least the key of the government, the private key of the government we trust. So in that sense, we can trust the key given to us. So I can trust my colleague's key that was given to him because my colleague needs to prove his identity to first the government, and if he has another key pair from the private companies. So if we combine the concepts that we just looked at and we think a bit through, we can see how we can prove digital signature, how we can achieve digital signatures in documents. So we have the producer who makes the file. So I write the file. I provide you the file as is. It's a PDF, a Word file, doesn't matter. I provide you the hash of that file, encrypted using my private key. I don't distribute that. You don't have access to that. And I also give you the public key. So you get three things. You get the data, you get the hash, and you get my public key. You, the consumer, what you can do is you can take that original data, and then you can create your own hash. You take my hash, hash B on the slide, and then you decrypt that using my public key, which is freely available, and that gets you the hash. If those hashes are aligning together, then the document has not been changed. That's good. That's a process that we have for digital signatures and documents. In a nutshell, in about 5 to 10 minutes. I haven't been watching the clock for that. So have the goals been met? I think they have, right? We have integrity. The hashes are identical. Authenticity, the identity is stored in the key, so you can read it out from the key. If you've never played around with it, there's a lot of tools that allow you to look inside of keys. And you can also add timestamps if you want to. Non-repudiation has also been achieved because my document has been signed with my private key, which, of course, is only assigned to me and to nobody else. Nobody else should have it. It's my responsibility that if my key has been compromised or lost, that I should make it an invalid key. I should, I forgot the word. I should, I should make note of it that it's been lost. So in that way, you can prove my identity because it's been registered at the government or registered at the private company or organization that distributes these keys. So how does C2PA use these? I think it's a given that these are included into the manifest file, right? So we have the manifest file. It's signed. It's tied to the document. We have integrity. We can prove whether or not the manifest and the document itself has been changed or not. We have authenticity, which is given through the keys that are included as well. We have non-repudiation, which is also included through the use of the signing. The act of signing proves that I am the author of it. But the most important one, at least in the case of C2PA, is authenticity. So I wanted to highlight again, certificate authorities, they are the key to this, pun non intended, they are key to this whole structure, this whole web of trust, as they call it, where we need to prove the identity of the signer. So you have multiple, you also have open source CAs that you can use. So if you don't have an open source certificate, feel free to check it out. But it's a way to prove the identity, and these are fundamental to the whole structure of it. Yeah, so they prove the certificate used to sign. Then I want to round off with a real-world use case. So I mentioned Canon. They have, you know Canon, right? The camera company. They have a prototype with Reuters, which is a news agency, and they have a new photo authentication technology. I think the headline used here is a bit not accurately describing the content because it's not just photo authentication technology, it's C2PA. But what they do is they have a prototype Canon camera. I'm not sure if it's legible on the screen, but it's in the first paragraph and the only paragraph there. And they have an actual device that you take a picture, included is the location data, what type of camera was used. So it's a C2PA compliant device. And then throughout its history, so you take a picture, then you edit it. Every time you make changes to the images, everything gets added to the C2PA manifest files. And that's working, and you can't check it out, but you can check out the article at least. Okay, that's my time. I've gone a bit too quickly, so we have time for questions, if any. I'll be happy to take them now or on the floor if you don't want to raise your voice now. Thank you. Yes?
I'm not quite sure if I understand your approach correctly. So what you suggest is to identify AI content, all content has to be signed by the author.
I think so. The question is, should all AI content be signed? Is that your question?
Every content.
Every content.
So because if you want to decide if content is
Hmm.
AI generated, and the only way to do it is to look at the digital signature,
Hmm.
means every content needs to be signed.
Not necessarily. So not every content needs to be signed. Every content that is meaningful, I would say, or at least important, needs to be signed.
Okay, so this is what I'm asking.
Hmm.
Do you don't you think this has a negative impact on open speech?
I wouldn't go as far as that. I would love to hear your reasons why it would impact open speech, because I
If you have this the digital signature
mhm.
that says, for instance, I mean this is okay for pictures, but for normal texts, for
Yeah.
instance, critics on the government,
Hmm.
and to see that this is not AI generated, I have to sign this with my name.
Yeah.
And if I don't do this, government could say, oh, this is AI generated, it doesn't count. Nobody thinks that what is written there.
Mhm.
So to prove that this is correct, this is by humans, I have to sign it. But then government knows who wrote that.
Mhm.
And if you don't have let's call it a good government, you might be in trouble.
Yeah. So the question or remark more is like, what if you are living in a country or a region that has an oppressive or authoritative government that you won't want to have your name associated with your message, basically? Because a signature does imply, at least one provided by CA, implies that you authorize yourself, authenticate yourself, that you prove who you are. And in some regiments, you don't want that. That's to put it very lightly. And I think that's a very valid concern, and that is a side effect of how digital signatures work, right, and how keys work. It's not the initial output, or at least outset of the C2PA specification, and it's not trying to solve that problem, because that is a problem in general with the whole political situation in those regions. I can already think of a few ways to solve that, and it is by using external parties that can vouch for your content, like using a third-party NGO that can sign it, like have Amnesty International publish your texts or some, although they might not be the most trustworthy ones. I'm just giving examples off the top of my head, right? But that might be a solution to solve that. And I think in a way that would be how people would get their messages out already, through proxies, through VPN, through whatever third parties that they can find. I think that is not going to change that much. It's going to make it a bit more. It's an extra step if you want to make sure that it's not AI generated. To most sure, but that's a valid concern to have. But I don't think it's a problem with C2PA in itself, but more with like the situation itself. But I get the concern, and I completely agree with the concerns, but I don't think C2PA applies to this. Yes.
I think there's an inherent problem. If you want to be anonymous, there is no way to distinguish you from an AI. But also, I'd like to ask, is there any support in browsers for C2PA? Like kind of where, like we see, if there's a valid signature backing or valid
Mhm.
certificate backing our HTTPS connection, we see the padlock because it's integrated
Yeah.
in the browsers. And we have the same with simplifying logging into systems using
Mhm.
browser-embedded technology. Is there any progress of embedding C2PA into browsers so that the browser can show us what content has
Yeah.
a certificate?
Okay, so the question was, first there was a remark on anonymity and and signatures, and let's have that discussion afterwards because that's an interesting discussion outside of this talk. But the main question was, is there any browser support for this or any support in general, let's call it. It's a relatively new standard released last year or 2 years ago. I'm looking at my colleague, but I'm not really sure of any browser support. I do know that Adobe has open source libraries to validate and extract manifest files, as do have other companies, open source MIT licensed, so you're free to check it out, improve it, use it as you see. We are also thinking about open sourcing our own stuff that we've implemented privately, but that is a process because we are not. We didn't develop in the open source initially. But I don't know if there's any open source support, browser support, sorry. But given that there are open source tools, I would imagine that there is already a plugin available for it. And if not, then some people might get inspired right now to build one. Any other questions that we have? Yeah, you against the light.
What if the private key gets leaked? Then suddenly all the images with that using that key, they would become unsure.
Okay, so the question was, what if the private key gets leaked? What happens to all the previously signed messages and files? Well, if I may do a very small marketing stunt, that is in my longer digital signatures presentation. So I did have to cut some content on it. And the main solution to this would be to timestamp your documents. So I remember the word now. So you revoke your license as soon as it got leaked. You basically let the authority know, like, this key should not be used anymore. If you find anything, it gets on a list, and you can find a list of revoked keys. Or you can ask the status of the revocation status of a key. If you insert timestamps into yours, if you add the timestamp signature, that basically ties a signature to a point in time. That's what it does, right? It's a timestamp. And you can prove that the timestamp was added at, let's say your key was leaked yesterday, the 4th. I think it's the 4th yesterday. And you signed the 3rd, you added the timestamp on the 3rd, meaning that any signatures going forward should not be trusted that don't have a timestamp, because you can prove that the timestamp signature was added before the revocation date. Does that answer your question? Sorry, I don't see you well against the light.
More or less.
Okay. But again, it's longer and better explained in my digital signature stocks, which I think I gave one at Devox as well a few years back.
I'll look at that.
Yeah, thank you. Okay, I don't see any other raised hands or concerned looks. Okay. Well, thank you. If you want to talk, we're in the booth in the corner at the exhibition floor. Thank you.